Forensic Science Lecture 14-2, Searching the Fire Scene. Arson investigators need to begin examining a fire scene for any signs of arson as soon as the fire has been extinguished. Most arsons are started with some sort of accelerant, which is any material used to start and sustain a fire. Things like gasoline, kerosene, those tend to be the the most common. They also need to look for any ignition device, and due to the fact that most of them are started with an accelerant, so there's something that has to hold it. Other common signs is irregular shaped patterns on the floor and the ground. They also need to look for any signs of breaking and entering, any theft that may have occurred that the arsonist might want to be covering up. Ignition device can range anywhere from a candle to a time delay device where they have a chance to set it and put it and then get away before the fire actually starts. When we're talking about time in an arson investigation, it constantly works against the investigator. And this is because residue may evaporate within a few days or even hours. There may be safety and health conditions that necessitate the cleanup and salvage operation to begin very quickly. If there is accelerants in soil or vegetation, it can be degraded by the bacteria that's present. And because of these factors, it is necessary to begin immediate investigation. This actually takes precedence over obtaining a search warrant, and the Supreme Court does address this and does give permission to begin the investigation before a search warrant is obtained. So the first part of a search needs to focus on the fire's origin. A search for the accelerant or the ignition device is the best place to start. Some other signs of arson may include evidence of separate and unconnected fires. In other words, they're setting them in separate rooms to make it spread faster. Also, the use of streamers to spread the fire from one room to another. So these can be trails of gasoline or paper that has been strung from one room to another to quicken how fast the fire spreads. And then evidence of severe burning around the floor due to a flammable liquid. Fire tends to move in an upward direction, so probable origins are going to be at the lowest point and then show the most intense characteristics of burning. Investigators, though, need to remember how heat transfers because it can cause the fire to move through a structure differently. Using patterns such as depth of the char, V-shaped patterns, or low intense burn areas as an indicator can actually be misleading. Airflow currents due to convection through a burning room can become the dominant factor in creating the burn patterns. But once the origin is located, it should be protected to prevent careful investigation. Nothing should be touched or moved, of course, before notes, sketches, and photographs are taken. So when they're searching for an accelerant, combustible liquids are rarely entirely consumed by a fire. Portions of them will seep into any porous surface, whether it's cracks or fibers, but most of the time, some of the liquid remains. So traces of flammable liquid residue can be located by what's called a vapor detector. It's also called a sniffer. And what it does is rapidly screen the suspect material for volatile residue. Such devices are not conclusive, but they're a very good screening device. Another approach that investigators use are dogs who've been trained to locate or sniff out accelerants. But during the collection and preservation of any arson evidence, of course, the typical safety precautions need to be taken to ensure no contamination. But when collecting 2 to 3 quarts of the ash or the soot should be collected and stored in an airtight container, as well as any porous material that may contain the residue of the accelerant. Specimens should be packaged immediately in airtight containers so that that residue doesn't evaporate. A can is the best. Paint cans, clean paint cans are the best for fire evidence, but jars could also be used, and they should be filled anywhere from a half to 2/3 of the way full, leaving airspace above the debris, which we'll discuss why in a minute. But if there's any large debris, it needs to be cut into smaller sizes so it can fit into those containers. In fire investigation, plastic bags are not suitable. Plastic bags can react with accelerants and permit vapors to escape, which then is pointless to collect that evidence. While collecting the evidence, it's also important that sampling of similar but uncontaminated controlled specimens are collected. Those are what we know as substrate controls. The lab's going to test the control to ensure that it's free of any flammables. And what this does is reduce the possibility that they were exposed to flammables, such as any cleaning solutions during normal maintenance. So once it goes to court, they can't say, well, it was cleaned with this and this is what actually started the fire. It wasn't put there. So what they're doing is eliminating any of the possible arguments on the side of the suspect. So igniters and other devices, typically the most common is a match. Other devices include burning cigarettes, firearms and ammunition, electrical sparking devices, and parts of a Molotov cocktail. And this is a glass bottle that contains flammable liquids with a cloth rag that's stuffed in it and then lit as a fuse. Relatively complex devices are less likely to be completely destroyed in a fire, and so they want to look for any of these remnants. If an arrest is made within a few hours, the suspect's clothes may or should be obtained and packaged separately in an airtight container, because there can be residual accelerants that are detected or can be detected by the lab. Once it gets to the lab, the most common and most successful test is the gas chromatography. It's the most sensitive and reliable instrument for detecting and characterizing flammable residues. The majority of arsons are initiated by what's known as a petroleum distillates, and these gasoline, kerosene, and they're composed of complex mixtures of what we call hydrocarbons, and these are compounds consisting of only carbon and hydrogen. So the gas chromatography separates those components and produces a characteristic pattern for each of these petroleum products. In order to get that residue from the sample, the easiest way of recovering it is known as what's called the headspace technique. So the airtight container is heated and the volatile substances then vaporize and are trapped in that airspace. And this is why the container should not be filled all the way, only halfway or 2/3. The vapor, or what's called the headspace, is removed with a syringe. And then injected into a gas chromatography, separated and recorded on a chromatograph. There is a database that's known as the Ignitable Liquids Reference Collection, or ILRC, and this is available so that they compare the peaks of the sample with the known substances. And there's approximately 500 ignitable liquids within the ILRC. There is a disadvantage to the headspace technique, and this is the limited volume due to the size of the syringe. So an augmented technique is called a vapor concentration, and this is where a charcoal strip is placed inside of the container. Then it's heated to 60 degrees Celsius for about an hour. The charcoal absorbs a significant amount of the vapor in a short period of time, so it is much faster, and they can obtain more. The gas strip is then removed, washed with a small amount of solvent, and then that solvent is then injected into the gas chromatography. The main advantage here is the sensitivity. It's actually 100 times more sensitive than the headspace technique. So this is the one that they're going to kind of go for. They can get more of a sample here. On occasion, the patterns that are obtained through gas chromatography are not able to be read. And this could be due to a combination of accelerants, or that the residue mixed with the heat generated products from the fire scene itself. And so when they can take these readings and then use a mass spectrometer to help to simplify that. And by doing that, what they're doing is they're separating those components in the gas chromatography, and then they're sent through a mass spectrometer, which are then fragmented into ions. The analysis can then control the ions that are going to be detected. So they basically act as a filter to see only peaks of accelerants that may have been used. So it kind of eliminates the background noise of the gas chromatography reading. This ends lecture 14-2. There's a quiz next class.